Hey, what up, everybody? Welcome back. It's great to see everybody again. I trust everyone's doing well. Who, me? I'm doing fine, but let's not get into it. Let's just talk about how our baby calculus unit starts to heat up right about now. Not in terms of difficulty too much, but just in terms of like grasping the big concept of what we're even doing. So up until now, you're probably pretty lost about why we've been doing the things we've been doing. It doesn't make any sense. Today, hopefully, that should come together a little bit because it's all about graphs. It's all about slopes. It's all about tangents. If you don't know what those words are, I'm going to go over them. So you found derivatives using the power rule so far, but you don't really know what a derivative is. So today is all about like what even is a derivative anyway? That's a question mark. Okay, guys. I've thought a lot over the years about how to explain this, and I think the simplest way to say it is that a derivative. Oh gosh, it's a slope machine. So, for instance, if you have a derivative, well, we'll get into it with this one actually, but really it's just a machine where if you put a number into a derivative, so if you have f prime of some machine and you like feed a 1 into it and then you get an 8 out of it, that 8 is a slope. This is a slope of a tangent line. Now, a tangent line is when you have a curve. Let's just switch up colors just because I can. Let's say you have a little upside-down parabola like this. A tangent line is a straight line that just barely touches the curve in one spot. So you can have lots of tangent lines on this curve I've drawn. Let's get a little zoomy. So like one tangent line could be here. Like a straight line that just barely touches the curve right there. That's a tangent line. It has a positive slope because it's going uphill. See this uphill direction thing? So that's a positive tangent line. Then if you move like your point over a little bit and try to draw a tangent through that, it looks something like this. Do you see how that's like still an uphill slope line, but it's like the slope got a little bit shallower? So that would be still a positive slope, but a little bit less of a positive slope. Up here at the vertex of the parabola, you're going to get a horizontal tangent line. This is going to come up later. Should we label it? Let's label it. Go back to black, and I want it to be a little smaller. This is a horizontal tangent line. Your homework's going to ask about those. Then, you guys, if we were to jump over, like put a point on this side right here and try to draw a tangent through there, so a straight line that touches there, that is a tangent line that has a negative slope because it has a downhill trajectory if you read it from left to right, which you always read graphs left to right. So this side over here is going uphill, this side over here is going downhill. It's a really messy diagram now. But yeah, that's what derivatives do. They just tell you the slope of a tangent line at a certain point on the curve. So if you feed a 1 into a derivative, you're asking the derivative to tell you the slope of a tangent line that goes through the curve at that exact point. If that sounded like gibberish, like another language, first of all, it is another language, but it'll become more clear with this example here. So let's look at this guy. F of x equals x cubed minus 3x squared minus 9x plus 13. This is what the graph would look like if you were to graph it on your calculator. Now, what do they want us to do here? I think they ask you guys to fill out this table. So here, let's draw the table. The table has x on the top, and it has f prime of x on the bottom. Then it does negative 3, negative 2, negative 1, then we'll get a 0 in there. They have you do all the numbers, but I'm going to skip a couple. 2, let's see, what is that point? 3, so let's do 3 as well, and 4. I guess I only skipped one number. You guys, they're asking you to use the derivative. So first thing we have to do is find the derivative of this function right here. So this function, what is the derivative? That's where we get to use our fancy power rule that I taught you guys last time. So f prime of x is equal to, drop that power out in front, the old pop and drop, get 3x squared minus 6x minus 9. So that is the derivative. This is the slope machine. So many colors. If you feed a number into that, it's going to tell you the slope of a tangent at that point on the curve. So to fill out this table, we first, I don't like this brown color. Let's go more orangey, and I want a little thicker. Let's feed a -3 into the derivative. So negative 3 into the derivative is f prime of -3 equals 3 times -3 squared minus 6 times -3 minus 9. At this point, you could certainly reach for your graphing calculator. Let me see, -3 squared is positive 9, times 3 is 27, minus 18, this, that, and the other. I believe this is positive 36. So I put a 36 in here. Now, what is that 36? You guys, because we put a number into the slope machine, a slope comes out of it. What that means is if you were to draw a tangent, and I'll draw up here on the curve, look up here, at -3, if I were to draw a tangent line like this, that tangent line would have a slope of -36. So slope equals -36. Now, you guys, if we fill out the rest of this table, if you put a -2 in this spot right here, in for all the x's, so feed it into the function, you would get out positive 15. So this would be a 15 right here. If you put a -1 into all those spots, you would get a 0. A 0 would produce -9. A 1 or a 2 would produce -9 as well. Yes, it does. And then the 3 makes a 0, and then the 4 makes 15. Okay, what are all those numbers? They're slopes. So let's look if that makes sense on the diagram. If you go to -2, so here whoops, my bad. I wanted highlighter. Here we found that -2 produces a slope of 15. So if I go back to the curve and put a dot right, see how -2 is right here on the curve? That's where the curve exists at -2. If you draw a tangent line through here, like this, and pretend that connected, that slope has a slope of 15, which makes sense. It's going uphill. It's not as, I can't highlight on the picture, but the slope of this is not quite as steep as the slope of this, which makes sense because 36 is a bigger number than 15. It has a higher slope. Now, you guys, look at my highlighter right here. A -1 got a 0. What does a slope of 0 look like? The slope of 0 looks like a horizontal line. So here, right at A, if I draw my tangent line, it goes directly through A and is totally flat. That's a slope of 0. Which makes sense that we got 0 out of the algebra, because like if you're, I always think of it like a surfboard, that if you're taking your little surfboard and kind of riding the wave here, that like as you get towards the top, like it's going to start to flatten out. Then once you go over the crest of that hill, you're going to start to get tangents that should be negative. Does our derivative support that? Look, 0 gives us a -9, which means at this spot right here, 0 on the curve, if I were to draw a tangent line through that, that looks like it has a slope of -9. Cool. Then at 2, that also has a slope of -9. That's because like your tangent would actually be on the other side of the curve at that point. It'd be like this. So like, yeah, these two guys are actually parallel, which is interesting. Then at 3, you get another 0. That's because you would have a horizontal tangent right there. So, you guys, the derivative is a slope machine. That's all it does. It tells you the slopes of tangents. Now, let's say that, let's start fresh here. For this example, find the values of x for which the derivative of f of x is equal to x cubed minus 9x squared, apologize for the handwriting, plus 13x minus 2 has a gradient of 2. Okay, first things first. They threw a British word at you. This right here, gradient. My first year teaching IB, I saw this in all the books, and I was like, well, that's stupid. I'm not going to use that word. I'm just going to use the other word. And then I used it. And then I got in trouble later on because they were like, took the IB exam, or like, Mr. Jolly, what the heck is a gradient? And I was like, oh, whoops. You guys, the gradient is just a fancy British word for slope. That's all it means. They're asking for when the slope is 2. So, if you're going to find when this curve has tangents, find the values of x for which the derivative, so the derivative is right there in the title. We know we're going to have to find the derivative. The derivative, when the derivative is equal to 2. Well, because they're asking a question about the derivative, we need to find the derivative. Should we go green? Haven't done green yet. So f prime of x, once again, use that power rule. So easy, pop and drop. 3x squared minus 18x plus 13. And then remember that the negative 2 on the end just goes away. Now, we want to know when that is equal to 2. That's not feeding a 2 into it. That's what do we feed into it to get a 2 out of it? So instead of putting a 2 in for x, we're going to replace this guy with a 2. 2 is equal to 3x squared minus 18x plus 13. Now, you guys, the whole reason that I did that little quadratic brush up on all this stuff is because you need to be able to solve problems like this. This is quadratic solving. This is algebra 2, straight up. First step I would do is I would subtract 2 from both sides. So get it all on one side. Get 3x squared minus 18x plus 11. Brutal. Really? What did I do wrong? Nope, I'm an idiot. Oh, no, wait. Are we going for 2 or negative 2? Oh, you guys, I goofed. This is going to get gnarly if I don't fix it. Back up here, I'll highlight it. This should have been a negative 2. My be negative. So that means I need to change this to negative 2. And then if you add 2 to both sides, then this green thing would become plus 15. My bad. Sorry. You guys, you might look at that and be like, I'm going to use the quadratic formula. And I would say, you're doing way too much work, buddy, because it's probably factorable. And then other kids might look at that and be like, oh, I'm going to use that smoke and mirrors thing that Mr. Jolly taught us. And I'm going to be like, that's awesome that you thought of that. But, you guys, do you see how this number, and this number are all divisible by 3? That means I can divide this side by 3 and this whole side by 3. And then we get 0 is equal to x squared minus 6x plus 5. Now, this is nicely factorable because I need to find 2 numbers that multiply to positive 5 and add to negative 6. They are negative 5 and negative 1. Then if you have 2 parentheses being multiplied to get 0, you set them both equal to 0. So x minus 5 equals 0 and x minus 1 is equal to 0. So our answers are 5 and 1. So those would be the points on the original curve where the tangents would have a slope of negative 2, which is what they were asking up there, but they asked it in a weird way. Okay, one last thing I'm going to show you guys. find the values of x where the function g of x is equal to x cubed minus 3x squared, no, sorry, 3 halves x squared minus 18x minus 1. Apologize, I'm going off the page there. Where it has a horizontal tangent line. Okay, you guys, this curve at certain points it has horizontal tangents. Now, what is a horizontal tangent? Let's back up all the way to here. Like a spot like this is a horizontal tangent. It's where like the curve sort of turns around, and if you're riding your little surfboard along the curve, it would flatten out and have a slope of 0. So that. Now, let's go back to our problem. Oh, wait. Back to here. You guys, the slope of that line is 0, which means that the slope machine spits out a 0 at those points. So we need to figure out when the derivative of this is equal to 0. First step, pop the derivative. G prime of x is equal to 3x squared minus, when the 2 comes out in front with the 2 times the negative 3 halves, the 2's on the top and bottom cancel out, so you just get minus 3x and then minus 18, and then remember that you just forget about the, remember to forget about the negative 1. Now, horizontal tangents have a slope of 0, so set the slope machine equal to 0 to figure out where the horizontal tangents happen. And then solve this like you would algebra 2 style. Everything's divisible by 3, so 0 equals x squared minus x minus 6. Two numbers that multiply to negative 6 and add to negative 1 are negative 3 and positive 2. Set them both equal to 0, and our answers are 3, negative 2. And then we're all Gucci. All right, guys. This is only part of 13.3. 13.3 is going to be your homework, but I'm only going to do part of it because we didn't get through all the examples. I'm going to save the rest for Monday because it's really too big of an assignment for one lesson. I would have to do like an hour-long video for you guys, and I'm not doing it.